Alright guys, this is lesson 4.3. This is our first video. There'll be two of these kind of explaining how we graph our other trig functions. So we spend a lot of time graphing sines and cosines, and you might be thinking, oh no, I don't want to spend just as much time graphing tangent, cotangent, secant, cosecant. And don't worry, you won't. We're going to leverage the time that we spent with sines and cosines and realizing, having spent that time, the other four trig functions are much, much easier and quicker to graph with the information from sines and cosines. Okay, before I kind of get into the lesson, I want to give you guys a joke, and I'd like to dedicate this joke to Mr. Stephen Lang. And here it goes. We have a Frenchman, an Englishman, and a New Yorker were captured by cannibals. The chief cannibal told them, "You will each be killed and eaten. Then we will use your skins to build a canoe. Tell me, how do you want to die?" The Frenchman asked for a sword, shouted, "Vive la France!" and threw himself on the blade. The Englishman asked for a gun, shouted, "God save the Queen!" and blew his brains out. The New Yorker asked for a fork and immediately started jabbing himself all over his body till blood was pouring out through hundreds of holes. "What are you doing?" demanded the chief. The New Yorker snapped back, "There goes your canoe." Yep, that was a pause for laughter, by the way. All right, so now let's get into our graphing here. And like I said, we want to leverage the information we learned from sine and cosine, and we want to use that to make secants and cosecants very easy. So to begin with, let's start with a secant graph. And the first thing you want to remember is a secant is related to cosine. The secant is a reciprocal of cosine. And then when we get into the cosecant, remember cosecant is reciprocal of sine. So come over here on the right and remind yourself what a cosine graph looks like. And then for a secant graph, we're just going to take the reciprocals. So let's just kind of sketch this over here on our graph on the right. And maybe here when x is 0, the y-coordinate is 1. What's the reciprocal of 1? 1. How about over here? Maybe when the y-coordinate is a half. So if the y-coordinate, look over here, it's about a half, roughly. What's the reciprocal of a half? It's 2. So now we come up to about here. So we start getting points like this. And just to get, oops, I erased one I didn't want to. So reciprocal of 1 is 1. Reciprocal of 2 is a half. We're down here in the negatives. What's the reciprocal of negative 1? Negative 1. How about when it's negative a half? Negative 2. Oh, look, we have that on both sides. That looks like about a half again. The reciprocal is 2. Over here, the reciprocal is 1. A half is 2. We start to get these points on the graph. And then you want to look right here at these places where the cosine is 0. And you should know, what is the reciprocal of 0? The reciprocal of 0 is undefined. So we're going to have parts of our graph that do not make any sense, where we're going to have asymptotes. So right here, where our cosine was 0, we can't take the reciprocal of 0. So we sketch in a vertical line. And again, right here where the cosine is 0, you can't take the reciprocal of 0. You sketch in a vertical line, and you start to get a sense now of what the graph of the secant is going to look like. Connect those dots. Connect those dots. Connect these dots. And we get our sense of a secant graph. Let's just put this on our calculator and see what it looks like, just to verify that we're doing this correctly. We are. Never hurts to check. Mode. Make sure you're in radians. That looks good. Quit out of here. Let's go y equals. Let's first graph a cosine graph, just for a reference point. And then our secant is 1 divided by cosine. And let's graph those. For a window, let's choose zoom trig. And here comes my cosine graph. Looks good. And here comes my secant graph. So it's just going to be these loops coming off the top and bottom. I like that graph better. I don't think I'm going to sketch this by hand. Let's just take their graph, put it right in here. And again, how do we do this? Easiest is, look, where was the cosine 0? Right here, right here, right here, right here. You can't take the reciprocal of 0. So we'll sketch in those vertical asymptotes. And then the secant graph is just these little loops coming off the top and these little loops coming off the bottom. Some people look at those loops and say, oh, look, it's a bunch of parabolas. Well, it's not quite parabolas because parabolas actually aren't bounded by any asymptotes, but they look very similar to parabolas. We won't call them technically a parabola, but I can see why somebody might think they're very similar to a parabola because they certainly look a little bit like a parabola. Okay, that is our secant graph. It's just that simple. Let's turn the page. Some key points for a secant graph. You might want to write these down, or you might just want to go back to your cosine graph and say, oh, I get all my key points from knowing my cosine graph right here. But let's just look at them anyway. Okay, what is the cosine of 0? It's 1. So what's the secant of 0? It's 1. What's the cosine of pi? -1. What's the secant of pi? -1. That's just reciprocals. I could have put 2 pi on here also, I guess, for another key point. Secant of 2 pi is the same as the cosine of 2 pi, which is 1. Where can you not take the reciprocal? You can't take the reciprocal when the cosine is 0. Where would that happen? At pi halves, 3 pi halves, if you keep rotating around, 5 pi halves, etc. Okay, easiest to just remember the cosine graph. But if you want to write down some key points, these are the key points. All right, let's do the cosecant graph. No big surprise here. We're going to start over here with our sine graph. So y equals sine of x. Just like the secant graph, it's going to be the reciprocal. I can't take the reciprocal where the sine graph is 0. I sketch it in vertical asymptotes. What's the reciprocal of 1? 1. How about here with the y-coordinates a half? Reciprocal is 2. Oh, look, it's getting smaller. So the reciprocal keeps getting bigger and bigger and bigger. And this looks just like our secant graph, except it's a cosecant graph, so it's shifted a little bit, just like a sine and cosine are similar with the shift. What are our key points on this? Same thing as the sine's key points. Pi halves, 3 pi halves, the sine is 1 or -1, so the reciprocals are 1, -1. Where can you not take the reciprocal? When the sine is 0, so at 0, pi, 2 pi, etc. Okay, let's just verify that with our calculator as well. So now I'm graphing sine, just for reference. And then down here I'll go 1 divided by sine. So hopefully you're looking at this thinking, oh, this is nice and easy. There's my sine graph. And I get these little loops, don't call it a parabola, but little loops coming off the top and bottom of my sine graph. All right, let's save that here for that picture. That's a pretty nice picture of our cosecant graph. All right, so now let's practice a couple of these by hand. And when we do our graphs by hand, we remember this important fact. If I want to graph a secant or a cosecant, don't do it. Instead, just graph the corresponding sine or cosine, and then use that graph to get your graph of the secant or the cosecant. Okay, let's try one of these. So here's a question, y equals 3 cosecant of x. I'm going to translate that, and I'm going to graph y equals 3, reciprocal of cosecant is sine of x. And you spend a lot of time graphing sines, and hopefully you look at this one thinking, ooh, this is not bad at all. The amplitude is 3, so it comes up to 3. Down to -3. We know our key points for sine or cosine are pi halves, pi, 3 pi halves, 2 pi. We know our sine graph starts at 0, goes up to 1. I'm sorry, it goes up to 3 this time because the amplitude is 3, down to 0, down to -3, back up to 3. And this is my graph I'm using for the guide, so I'm just going to sketch that as kind of a dotted line, because it isn't really my real graph. I'm using that to guide me, and maybe I'll sketch a little more, going both ways here, so I can extend my cosecant graph as well. Okay, that's my guide. Once I've got that, let's put in some vertical asymptotes. Let's make them really nice. Let's put in something dotted, right? Something that will show up, though. Let's see, how about purple dotted lines should show up. So let's get our asymptotes. Where is the sine graph 0? Right here at pi, right here at 2 pi. You can keep going right here at 3 pi, right over here at 0, right over here at -pi. So those would be vertical asymptotes. And what does my cosecant graph look like? It's the little loops coming off the top of the sine graph. So it's bounded right there. There is my cosecant graph. And there is my cosecant graph. And, oops, right at 3. There is my cosecant graph. And over here is my cosecant graph. And that's the nice, easy way to graph sines and cosines. We'll do a couple more, but let's pause this right here for our first video.